whether is it started or not. So here we go. I will just write on the screen. That's why, yes, this was the point where we have to make a cross for question number one, and we have to write a C here. Again, we have to write a cross and we have to write a C here. And the in the other part, it is said that draw cross and mark a rarefaction. So this is rarefaction center, and this is basically the center of your rarefaction. So the important thing is here that the wavelength is 0.45. So can you tell me what will be the what will be the wavelength here, or where would be the wavelength? What should I draw for the wavelength? The wavelength is between two consecutive
Excessive.
compressions and rarefaction. Yes,
Yeah.
is it?
Yes. Yes.
This is your 0.4. So you are asked to draw 0.9. So actually, you are supposed to draw a line between two compressions, yani from this point to this point. So this line is actually your 2 lambda. So you are supposed to draw that 2 lambda. Got it? Then the frequency of the wave is 750 hertz. Calculate the speed of the wave. So easy approach, by using V equals to F lambda. You can calculate the speeds of your wave. Frequency is 750 times. Wavelength is 0.45. I will require calculators from your side. Yes,
33. 337.5.
3. Okay, you will write 337.5, but your answer would not be in these significant figures. You will write your answer into 340 meters per second. Are you getting my point? Because
So
there are
why
two
not
decimal.
338?
338 is three significant figures. So here in your data, you have two significant figure data.
Oh, okay, got it.
Okay, remember
Yeah.
this thing. Now suggest the medium through which the sound wave is traveling and state your reason. So suggest a medium which sound wave is traveling. And okay, so it is 340. So which medium is supposed to be this?
Air.
Air, or you can say gas, because the reason is obvious that the speed of air, yani speed of sound in air is almost from 330 to 340, right? 330 to 340 meters per second. Got it? Then another type of the wave that consists of two compressions and rarefactions of in ultrasound. That is the same thing, but that is ultrasound. State one other similarity between the sound and frequency of 750 hertz and ultrasound. So what does it mean? 750 hertz is audible or not?
It is no,
Yes.
yeah, it is
It is
audible.
audible. It is not audible. So this is basically the difference, right? So similarity is both are longitudinal wave, isn't it?
Yes.
Didn't it say that both consist of compression and
Yeah,
rarefaction?
longitudinal represents the same concept, long compressions and rarefactions. And secondly, both cannot travel through medium, right? Both can't travel through medium. Is this very clear to all?
Oh yes, sir.
Okay, so just a second, because the writing is okay. I have to switch my laptop's position. I have to make it in writing mode. Okay, so what is the next? The next is your difference, right? So in sound frequency is different than ultrasound. So
Mhm.
750 hertz is audible, right? And the other one, ultrasound, is not audible.
Do you get 2 separate mark for this?
No, no, no.
One
One
mark, right?
right. Yani 750 is audible. That's it. It's not a big deal.
Okay.
Okay. Sound is a longitudinal wave sketch that represents the longitudinal wave on your sketch. Indicate and label the distance. Okay, between distance to show the wavelengths. Mark and label the center of one compression, right? And what else you have to do? You have to mention the mark and label the center of rarefaction. So do you think that these all are yani this practice has been done in the previous question? Is it?
Yeah, actually, yes.
Yes. So that's why I will uh, prefer that you people can draw this type of wave by yourself without my help. Yani you have a choice. Either you draw the compression and rarefaction in the way which have been represented in the previous question, or you can draw them by your own choice. But simply, this is better idea that draw the compressions and then draw the rarefaction. Just increase the distance, then decrease the distance, then make them close, then increase the distance, then decrease the distance, and so on. So this is the rarefaction, this is the rarefaction, this is the compression, this is the compression, right? Is it clear to all? And
Yes.
Got it.
it's yani the easy way is sorry, the accurate way is just place your ruler, right? Because you have to score 3 marks, so at least it should be given 3 minutes. Place the ruler, and when you will place the ruler, for example, here is the ruler. I'm not having ruler in this software. Just select its center and 1 centimeter apart 2 points, then half centimeter apart 2 points, then quarter centimeter apart 2 points, then half centimeter apart 2 points, then full centimeter apart 2 points, then quarter, then half, and so on. So in this way, you will have very symmetric lines. Are you getting my point?
Yeah,
Yes.
This way,
getting it.
right? Okay, then the longitudinal wave passes one medium, another medium. The speed of the wave is slower in the second medium state. What happens to the frequency of the wave? What happens to frequency of the wave? Hurry up. During refraction, what happens to frequency?
It stays the same.
Yes.
Yes, stays the same. So this is a tricky question. So it stays the same. What about the wavelength of the wave?
It is
Increases.
different.
Yeah, the speed of the
Increases.
wave slows down. It means
So the
according
wavelength
to
increases.
v equals to f lambda, if v decreases, lambda decreases, so it decreases.
Yes.
Okay, and state the
Yes.
typical values of the speed of sound in air. Yes,
330 meters per second.
330.
yes, you can write 330 to 340 with unit any value. Okay, okay, should I move on?
Yes.
Yes.
Okay, in circle two following circle two of the following, that the ultrasound wave traveling in air. Okay,
Frequency 35,000 and longitudinal.
very good, because its frequency would be higher, so it would be 35,000 and it would be your longitudinal wave.
Longitudinal.
Okay, and what about its speeds? Speed is not given in any range because its speed will be isn't it in liquid traveling in air? Okay, if it is in air, then fine. If it would be in liquid, then this would be the right answer. Okay,
Okay.
calculate the wavelength in a vacuum of x-rays. Sorry. Calculate the wavelength in a vacuum of x-rays of the frequency this. Here you people have, most of the time the student is trapped and the student loses 3 marks just due to one reason कि यार सर speed कहाँ से लेके आऊं मैं. So do you think uh, how will I manage about the speed?
It has something to do with the vacuum, does it?
Vacuum is actually X-rays are there. So speed of the X-rays is the same as speed of light. So you will simply say it is
So
3.0
3
into 10 raised
into
power
10.
8 meter per second, and you have frequency that is 1.3 into 10 raised power 17 hertz. So now lambda is very easy to calculate. So lambda is equals to V upon F. So 3.0 into 10 raised power 8 divided by 1.3 into 10 raised power 17. So what would be the right answer?
is wait it's
Calculations, please.
going to be
2.3 into 10 raised to power minus 9.
yeah
Sorry,
saying
how much?
2.3 in
2.3 into 10 to the power minus 9.
Minus 9 meters. So 2.3. I mean, rounded off value. Probably is a maybe she has rounded off.
I think Isa got the same answer, didn't she?
yeah, I got the same.
Sam? Okay, good.
Mhm.
So this is basically your rounding of answer. Rounded off answer, actually. Okay. So moving
Yeah.
on. Ariba, are you there?
Open.
Hello,
Yes, sir, I
Ariba,
am.
are you there?
Sorry, my mic
Yes.
was
So
opening.
okay. ठीक है, तो माइक ऑफ रखोगी तो प्रैक्टिस के दौरान फिर मतलब हम कैसे मानेंगे कि आप प्रैक्टिस कर रही हैं?
Sir, I answered in the last question when they were talking about the frequency and the wavelength. Maybe you misheard my voice for someone else's.
Hmm. I mean, do you have any confusion in that?
No, sir.
Okay, okay, okay. Good
I
है
do
then.
have confusion in letter C, though. I'm not good with radioactivity.
Okay, radioactivity. तुम उसमें फंसी हुई हो radioactivity में? Oh, you were actually teacher in radioactivity. Then why? Huh?
Because the theory parts, like where they ask us like why this is dangerous, whether like I get confused in them.
No, no, no. They all are to be memorized. Yani in everything which is the fact based, understanding has nothing to do with. Okay, they are the facts. Okay, should I move forward?
Yes.
Okay, the next one is here. A dentist takes an X-ray photograph of the patient's teeth. Explain why it is safe for the patient to be close to the source of X-ray, but the dentist must stand away from the source. बताइए.
Is it
The
इसके
den-
डेंटिस्ट के पास more patients, काफी patients आते हैं तो
Mhm.
the dentist may be irradiated or something.
Yes, the dentist would have more dose because it has more exposure, है ना? The dentist have more uh, frequent exposure, frequent exposure to the X-rays. So he or she must stay away. ठीक है? As the patient has the X-rays only once. Is it? That's it. The next is state with a reason why the microwave oven are designed only to work when the door is closed. Wow. Oh, because the microwaves can damage the eyes, or microwaves can be dangerous. Is it
yes.
for the user?
Microwaves are dangerous.
Yeah, they can cause you know, a sort of burn. That's it, nothing else. Because we have water inside in our body, so they basically break the bonds of the water, and so mm, we get heated up. Yani the objects get heated up. You got it?
Yeah.
Yes.
Okay, so it's an easy task. Sound वाला topic कोई बहुत ज़्यादा problematic नहीं है. Go to this one, right? The loudspeaker is a sort of sound source, right? That wave of the that produces a wave of the constant frequency state. What is mean by the frequency? So what is frequency actually?
It is a
The
number of
number
thing in 1 minute second
thing a point.
produced in 1 second.
Okay, good. The number of waves produced in 1 second, number of oscillations produced in 1 second, that is actually your frequency. So you can say the number of waves are oscillations, because that is a speaker, loudspeaker. So you can simply say waves, no issue at all. Oscillation is a broadband idea. Oscillations per second. Instead of writing second, you will write unit time. Okay.
Okay.
Okay. Then in this, the sound wave is traveling. The sound wave travels in air towards the barrier with a small gap as the center. Figure 7.1 represents the compressions of the wave traveling towards the barrier. This is the diffraction question actually. The gap and wavelength are mentioned here. State what is mean by compression. What does it mean by compression? Yes. Ariba.
The compression, like the definition itself, right?
Yes, the part of medium, okay, where particles are. I have written half. You will tell me the remaining.
Well, it's like when the waves are closer together.
Yes, closer to each other or closer together. Yes, Izza and Zainab and Mariam. Are you people agreed?
Sorry, can we say concentrated?
Yes.
Yeah, you can say, but concentrated is something, yeah, you can write it.
Mm.
They have more pressure. Other than that, you can say they have more pressure rather than saying concentrated.
Oh, okay.
Okay?
Yeah, got it.
So, moving on, uh, here. The width of the gap is smaller than wavelength. This is the key point, smaller than wavelength. On figure 7.1, draw the pattern of the compressions after the sound wave has passed through the gap, right? So you have to draw the compressions, because when the wavelength would be greater than the gaps, you would draw the wave fronts, right? These wave fronts will be basically drawn in this way. First, put the scale, place the scale here, and just measure. It seems to be 1 centimeter. So just draw the points 1 centimeter apart, 2 or 3, not more than that. Then remove the scale, okay, and draw the circular paths, yani circular wavefronts here, so that you are going to ensure this thing, that the waves, sorry, this there is no bending taking place, right? There is no bending taking place. Bending mean decrease in the wavelength. Sorry, I was saying bending. No, there is no change in the wavelength takes place. That's why I told you that you have to ensure this thing. Okay.
Okay.
The next is the barrier is adjusted so that the gap becomes wider. The gaps become wider. Describe how this affects the patterns of the compressions after the sound wave has passed through the gap. So, what is your idea? I told you that there will be less bending observed, right? There will be less or smaller bending observed. Okay, is it clear to you?
Yes.
Okay. So then we have the question of frequency. The frequency of the sound wave is this. The speed of the sound is given to you. Calculate the wavelength. Very easy question. State typical value of the speed of the sound in the air. Liquid, it is almost 1500 meters per second, etc., etc. So I think so. The sound questions are not that much difficult as I was expecting. Here is one question what I have found for you for the ultrasound. Okay, the radio waves, ultrasound, and the visible light, all of the waves state what is meant by the ultrasound and suggest the value of the minimum possible frequency of the ultrasound. Yes. Uh, Iza.
Yes.
Okay. Iza, what do you think? What is the ultrasound? How will you state the ultrasound?
Ultrasound is are the sound which have higher frequency than 20,000 hertz
Okay, good.
and are not audible by normal humans.
Oh, well, that is not audible by normal humans. Good. So, moving on, Zainab will tell me what is the minimum frequency of that.
Audible by a human?
No, no,
Minimum
no. What is
frequency?
the minimum frequency for ultrasound?
20,000.
20,000? Confirm?
20, like above 20,000? Is it
Yeah.
20,000 and above or
Yani
like
20,000. You can write either 21,000, right? Above 20,000. So that's the minimum possible frequency, right? Is it clear?
mm-hmm.
Yes.
Okay. State the value of the waves are electromagnetic. State which of these waves are electromagnetic. Electromagnetic waves are, sorry. State which of these waves
To
are
scroll up.
electromagnetic. Sorry, electromagnetic waves are radio waves. You can
Infrared.
write infrared and so on. All anyone from the spectrum. And longitudinal are basically sound waves.
Sound.
Are the waves produced in the
Sir, could you
spectrum of.
scroll up for a second? Like,
Oh yes. I
where?
got the mystery. Yes, I got the mystery. Don't worry.
Okay. So, so radio waves and visible light would be electromagnetic.
Yes, visible light. All GXULIMR is your electromagnetic. Got it?
Yes.
Okay. Good. What about this question now? The ultrasound passes through where? Through the passes through both human flesh and bones. Figure 5.1 shows an ultrasound source sending an ultrasound wave into human flesh. Ultrasound source is there, flesh is there, bone is there, then flesh thickness T is given to you. The ultrasound wave travels through the flesh to the point X and then through the thickness of the bone to point Y. At Y, some of the ultrasound is reflected and returns to X. From Y, some of the ultrasound is reflected and returns to X. The total time taken for the ultrasound to travel in the bone from X to Y and back to X is 9 exponent minus 6 seconds. 9 exponent minus 6 seconds. So the speed of the ultrasound in the bone is 4100 meter per second. Calculate the thickness. Just calculate this and just give me 1 minute. I'm back. You have to calculate meanwhile. Assalamu alaikum.
Sir, what equations can be used in this?
I think we're using the speed is equals to distance on time.
Oh, because the thickness would be the distance, right?
Yeah.
Okay, thank you.
Yes. Is there any answer?
Yes, sir.
Okay, what's that?
I got 0.01845 meters.
Yes. How many of you are agreed with Mariam?
I'm just calculating, sir. I'll tell you right now.
Okay, so I have not to expose the answer. Yes, and Mariam, sorry, Zainab and ऊपर आओ बच्चे सारे उनको ऊपर भेजो एंड जैनब और क्या नाम है इज़ा आप लोगों का क्या सोल्यूशन है
Sir,
Sir, I got my answer.
ओके इज़ा एंड जैनब वेटिंग फॉर योर आंसर्स
एक सेकंड सर वो देख रही हूँ
ओके
I got my
ओके गुड 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 गुड
so did you know
Actually-
that we also have Khadija?
Khadija is there
Yes,
yeah
sir.
Khadija told me that she will be traveling and she will not be at open the mic so that's why I just did not disturb her
Oh, okay.
अरे हो गया नहीं जाओ जाके उनसे लेके आओ हाँ जी यस हो गया आंसर या मैं समझाऊं 5 लगे
Got the
I have
answer.
given you an arrow yes okay everyone done should I solve it for you देखो the distance traveled by the sound is t plus t right this is the total distance traveled by the sound Yani from x it moves to y, and then from y it comes back to x. So that is why the distance is equals to S is equals to VT, or you can say D is equals to V into T. This T is not thickness. So you have to use that this distance is 2 times thickness is equals to speed of the ultrasound is given to you 4100 meters, 4100, and the time taken is 9.0 into 10 raised power minus 6 seconds. So the thickness will be 4100 into 9.0 into 10 raised power minus 6 divided by 2. So did you people do in this way?
Yes,
Um,
sir.
So what answer is there?
I got 1.845 times 10 to the power minus 2.
Okay, 4 point.
yeah, same.
दोबारा बोलना.
1.845
Oh, sorry, 1.845 into 10 raised power.
-2.
minus 2.
That's
Yep.
great. 1.8 centimeter.
So I got it. Like you divided the whole thing with 2, but for me, I divided 9 into 10 to the power -6 with 2, and then I used the formula. So like, let's still get the same
Yeah,
answer.
same, same thing, no problem at all. So is it clear to all?
Okay. Yes, sir.
This was a hard question. I mean, not hard, but a bit. So these type of questions are supposed to be solved by you people. And then this is a question I have marked in the assignment. This is difficult for you. And you people will solve that.
Sir, what are we going to do in the next class?
In next class, we are going to have a test.
Of waves?
Waves, complete section.
Okay. And after that, I mean, what next work are we gonna do?
Actually, I can't uh, make it